Okay, this is going to be a two-part session to get the answers for the practice test pages 14 through 20. As you can see here, this is only pages 14 through 16. On the first one, it's going to be uranium. That is not a fossil fuel. Number two, inexhaustible energy source is going to be wind. Wind's never going to be able to run out. So again, we're uranium here, wind here. A renewable energy source, so it's something that we can kind of reuse. That's going to be biomass. Number four, a motor running a winch. In this one, what you have to do is you have to look at, first of all, you've got to figure out your power. Power is going to be expressed in watts. And in this situation, you need to find pressure, or power equals force times distance over time. So force times distance over time. So that's going to be, force is going to be 3 newtons multiplied by 6 meters, and that is over 60 seconds. And that's going to equal 0.3 watts. Now what you have to do with that, you have to look at the power down in this section. You got to use the 9 volts and the 500 milliamps. So when you got voltages and currents and things like that, the equation for power is P equals current, which is the I times V. So substitute and solve. So that's going to be 9 volts multiplied by 500 milliamps, which is the same as 0.5. That's going to equal 4.5 watts. Then the next step, you have to figure out, the actual question is asking you, what is the efficiency? So question number 4 does take a little bit of time, but it's asking about your efficiency. So now what you have to do, you have to take your 0.3 watts and divide that by your 4.5 watts. So of course the watts are going to cancel, and it's going to give you a number. Plug it into your calculator of 0.066, and we'll just say 7. Then you got to take that number and multiply it by 100. And that's going to give you 6.67%. So that's going to be choice B. Number 5, you're going to have to use Ohm's law. So Ohm's law is going to help you in many of the questions in this section. V is voltage, I is current, and R is resistance. So number 5, you are asked to find the current. So what I need to do now is set something up. I'm looking for current. Current is equal to V divided by R. Just plug in your values. So my voltage is going to be 1.5 volts over 15 ohms. Your answer is going to be 0.1. So 0.1 amps, option A. Number 6, calculate the total current. IT is total current. So if you look at all of these different resistors, 1, 2, 3 resistors in here. Each one's going to have a current passing through it. So again, using Ohm's law, if you're trying to find current, it's going to be V over R, and you need to do that for each one of these resistors. So in this parallel circuit, total current is going to be equal to the current going across resistor 1 plus the current going across resistor 2 plus the current going across resistor 3. So coming back over here to this equation, now start plugging in some values. So V over R for resistor 1, it's kind of hard to see. The V is going to be, for each one of these, 15 volts. So you've got 15 divided by this first resistor here is 470. So 15 over 470. And you're going to add current passing through resistor number 2. So that's 15 volts divided by 2200. So that's 2.2 kilo ohms. So that's 2200 ohms. Plus the current going through resistor 3. So again, 15 volts divided by, now this is 3.3 kilo ohms. So that's 3300. And again, this is all equal to IT. So when you plug that in your calculator, your total current should come out to 0.043 amps. So over here, option C is what you're looking for. Next one, number 7. You're asked to find the resistor that the voltage will have the greatest voltage drop. So in the series circuit, all you have to do is pick out which resistor has the largest value. So in this case, resistor number 1 is 220. Resistor number 2 is 470 ohms. Resistor number 3 is 1.2K, which is 1200 ohms. So obviously that's the biggest. And in a series circuit, the voltage drop is going to be the greatest when you have the largest resistor. So this is going to be option C. Number 8, use Ohm's law again. So V over IR. This is very important. If you are looking for I, I'm going to take a V and an R. So in this case, my voltage is 3.5 volts, and divide that by my resistance. This is kind of cloudy on your picture, but it's 470 ohms. So 3.5 divided by 470 is going to give you a current of 0.007 amps. Now, if 0.007 amps is not an option, which there is not an option for 0.007 amps, you need to convert this, and it looks like it's going to be one of these two for milliamps. So milli, remember you're moving the decimal place 3 points. 1, 2, 3. So that's going to equal 7 milliamps. So number 8 is C. 9, same thing. Ohm's law. V over IR. You are being asked to find the voltage at this point. So now what you're going to have to do is you have to set voltage equal to these two variables here. So I and R are next to each other. So in this case, you're multiplying I times R. Again, I is your current, R is your resistance. Plug in your known values here. So V, we don't know. That's equal to I of, what do we got here? 1.4 milliamps. So when you plug that into your calculator, you want to convert it to amps. So that's 0.0014 amps. That's the same thing as saying 1.4 milliamps. And then you're just going to multiply that by the resistance of 22K. So 22K, again, you're going to have to convert that as well. That's going to be 22,000. Then you're going to come up with an answer of 30.8 volts. So, option A is your correct answer. 10. Calculate the total resistance. So in this one, you're looking for the R total. Actually pretty simple in the series circuit. All you have to do is add these three resistors together. So it's kind of hard to see, again, from the screen, but you look at it on your paper. The first one is 820 ohms. And then you just add the next one, which is 1.2 kilo ohms. So that's the same thing as 1200 ohms. And then you just go ahead and add the third resistor, which in this case is just 150 ohms. That's going to give you a grand total of 2170. 2170 ohms. So, D is what we're looking for. Number 11. It's asking you to find the total resistance. Now you got to be careful on this one. This is a parallel circuit. In parallel circuits, you always need to remember, it does not seem right, but when you have all these resistors in parallel, your answer is always going to be less than the lowest value resistor that you have. So in this case, we've got 5600 ohms for resistor 1, 680 ohms for resistor 2, and then 8.2 kilo ohms, which is 8200 ohms for resistor 3. To find your resistance total in a parallel circuit, the equation is 1 all over 1 over R1 plus 1 over R2 plus 1 over R3. So now you plug in your values. So in this case, 1 over R1 is 5600, so 1 over 5600 plus 1 over 680 supposed to be an 8, and plus 1 over the resistor 3, which is 8200. So plug it in your calculator, and then don't forget, this is all over 1. Your resistance total is going to be, my calculator says 564.61 ohms. So there may be a little bit of a rounding issue somewhere along the line, but I can see that option C right here is going to give me my answer. So number 11 is C. Number 12, 2 lamps are wired in parallel. If a lamp is added in parallel, what's going to happen? Again, resistors in a parallel circuit, that's going to result in a decreased resistance. So you have 2 light bulbs. You've got to look at the light bulb not as something that's going to do an output, but it's actually going to draw some current. It's going to draw voltage, things like that. You can all attest and know that your light bulbs are not going to just turn on magically. Something has to make them work. So that is going to act as a resistor. So the filament in the light bulb acts as a resistor. So in this case, number 12, D is going to be your answer because the total resistance will decrease. So if you add resistors together in a parallel circuit, the resistance will decrease. So that was just like number 11 on the last page. Jumping over here to number 13. When measuring amps, the multimeter is placed within the circuit. So the multimeter becomes part of the circuit. If you don't do this, if you don't switch over and change your multimeter to amps and actually run the circuit through the multimeter, the circuit becomes part of the multimeter, you will blow the fuse in the multimeter if it's fused. If not, you're going to damage just the whole multimeter. So you got to be really careful on that. Remember, the only one that becomes part of the circuit is when you're doing amperage. Number 14, electromotive force is just another term for voltage. Number 15, what you're being asked to do is first and foremost figure out which one of these two pictures is going to give you a way of measuring voltage. So number 15A, which one is going to allow you to measure voltage? So is it going to be figure 7 or is it going to be figure 8? In figure 7, what you're doing is you're actually making it part of the circuit. So that is kind of set up to where it would be running and checking for amperage. Figure 8 is what you're looking for, because when you're measuring voltage, you're going to measure across a component. So if this is the motor here, you're measuring across it. So you're trying to figure out what voltage is going through it. So you're automatically going to eliminate option C and option D, because those are talking about figure 7. Now you've got to look at the second part. So 15B, it says if the amount of current in the circuit is equal to 0.625 amps, what's the voltage value of the power supply? Ohm's law comes back again. So you are being asked, what is voltage? So I don't know. All I know is that I've got a V and I've got an I and an R. So I'm going to multiply the I times R. So current times resistance. In this case, I've got a current of 0.625 amps. Oops. 0.625. Don't make fun of my drawings. And then multiply that by a resistance. And we're looking for a resistance up here of 16 ohms. So you got to look at your drawing and find your resistance. So 0.625 voltage is going to be equal to 0.625 multiplied by 16. That should give you 10. So my answer is B. So figure 8 is measuring correctly and it's giving me 10 volts. That's going to be it for this one. Pages 17 through 20 will be on the next show.